The DNA doesn't lie. When researchers examined the Y chromosome of King Richard III, they uncovered a truth no historian could have predicted. The genetic trail broke, there was no match between Richard and his supposed male line descendants alive today. What they found wasn't just a royal mystery. It was a revelation that rewrote part of England's history. For centuries, the fate of Richard III had been one of Britain's great unsolved puzzles. He was the last English king to die in battle, struck down in 1485 at Bosworth Field. History said his body was brought to Leicester and buried at the Greyfriars Church. But the church vanished long ago, and with it, the king's grave, until one unlikely summer day in 2012. Guided by old maps and a historian's intuition, archaeologists began an excavation beneath an ordinary city parking lot. Few expected results. Yet, on the very first day, they unearthed human bones. The grave was hastily dug, too short for the body, and the head was awkwardly bent forward, hardly a burial fit for a monarch. As scientists brushed away the soil, the bones began to speak. The remains belonged to a man in his early 30s, bearing multiple battle injuries, 10 in total, 8 of them to the skull. His final moments had been brutal. 2 fatal blows pierced his head, one from a sword, another from a halberd, splitting the skull. But there was more. The spine curved sharply to one side at scoliosis, confirming the centuries-old image of Richard's uneven shoulders, twisted by legend into the myth of a hunchback. Everything seemed to point to one extraordinary conclusion: after more than 500 years, they had found King Richard III. But archaeology alone wasn't enough. To be certain, scientists turned to DNA, the most powerful evidence of all. Extracting genetic material from centuries-old bones was a delicate process. Working in sterile cleanrooms, the team drilled into a tooth and the dense femur bone, searching for DNA that could survive half a millennium underground. They compared it with living relatives traced through Richard's maternal line, descendants of his sister, and of York. 2 modern individuals agreed to participate. When their mitochondrial DNA was tested, it perfectly matched the sample from the ancient skeleton. Statistically, the odds of coincidence were almost impossible. The proof was overwhelming: the body beneath the parking lot truly belonged to England's lost king. The world celebrated. But then came a twist no one expected. The scientists ran one final analysis: the Y chromosome, passed only from father to son. In theory, it should have matched the male line descendants of Richard's royal ancestors. It didn't. The results were a complete mismatch. Somewhere in the 19 generations separating Richard III from his modern relatives, the bloodline had been broken. It meant that, at some point in royal history, a child was born from an affair, an heir who was not the legitimate son of his father. This single discovery called into question the entire idea of an unbroken royal lineage. Was Richard III himself truly of royal blood? Or did the break occur later, among his descendants? Scientists couldn't identify the exact generation, but the implications were enormous. If the false paternity had occurred before Richard's birth, his own claim to the throne might have been invalid. The Wars of the Roses, decades of brutal conflict over royal legitimacy, could have been fought over a lie written in DNA. Even if the break happened later, it proved something deeper: that no royal bloodline is truly pure. Genetic studies show that false paternity happens in about 1 or 2% of births per generation, a small number, but across centuries, almost inevitable. And the irony was haunting. Richard III had claimed the throne by declaring his nephews illegitimate only for his own DNA to expose a hidden illegitimacy within the dynasty itself. Yet science didn't just uncover scandal. It also gave the world a more human portrait of Richard. CT scans and facial reconstruction revealed a man far removed from Shakespeare's villain: youthful, thoughtful, and even handsome. His DNA indicated blue eyes and fair hair that darkened with age. His scoliosis, though severe, didn't cripple him. He could still fight, ride, and wear armor. His skeleton told a story of courage, not cowardice. The fatal wounds proved he had faced his attackers head-on, surrounded and outnumbered, fighting to the end. Even in death, his enemies humiliated him, stabbing his body and displaying it in the streets. But centuries later, science restored his dignity, showing that he died as a warrior king, not a monster. And so, the DNA of a long-dead monarch did more than identify a skeleton.
It revealed a hidden scandal, challenged the myth of royal purity, and redefined our understanding of one of history's most misunderstood kings.